Hello, I'm Chris Athanas. I'm a KMP developer. Tech Sport's coming out Tuesday to close that thing up. Today I'm going to be reacting to one of my favorite backend YouTubers, and he called Code Opinion, and this is just like he does get kind of technical into the weeds, backend languagey stuff, but I'm going to do a little bit of a translator as it goes along for just people that may not have back-end experience and maybe coming from the front end, which is where I came from, Android and browser technology. But so I'm not the best at the back end, but I know enough to get the MVPs going, and that's all you need, really.
Hey everybody, it's Derek Martin from CodeOpinion.com. I'm a big fan of the WebQ worker pattern. It's a great pattern that can use with different architectural styles such as microservices or modular monolith. It doesn't really matter. It has a lot of scaling benefits where you can move work into the background, as well as if you have a lot of workflows or business processes that are long running, or you have reoccurring batch jobs. So here's the WebQ worker pattern in its simplest form. We have our client make a request to our HTTP API. This is the web portion. From there, what it's doing is that request is going to need to do something, perform some type of action. So what's doing is creating a message to represent that and placing that on our queue. At that point, our requests from our client to our HTTP API to our web portion, we're done. The third step of this is having a worker. It's the one consuming messages and pulling messages off our queue to perform whatever work was actually requested. This could be, my example, interacting with our database, making some type of state change. But there's some dogma that can come with this if requested.
All right, so all this stuff right here, this is all one application. Now, in the world of backend, these could actually be all separate things. I'm talking about this particular portion here, this HTTP API, the queue, the database, the worker. This is what I'm recommending is to start off with a modular monolith that does this using Ktor, and I'll probably do some examples of that in this series. And this client could be your web, could be your iOS app, could be your Android app, could be a desktop app, any of the KMP applications that are desktop application targets that are available. That's what this client is, and this is of course going over the internet. And this is all within Ktor and all written in Kotlin. So the queue can be simulated inside the modular monolith as a channel or a flow. That's probably the best way to do it. Or it could be a file-based, and there might be some other libraries that can handle this queuing stuff. So, I mean, but you don't really, just put it in RAM. It's going to be fine. It's going to be fine. Like for the MVP. Eventually, you might need to go more persistent and put this queue into something like Redis, but in the beginning, you probably don't need to do that. But the Redis can handle this queue. The Redis can handle the database. This worker is just the processing inside the web app. That's all that's going on there.
This could be, my example, interacting with our database, making some type of state change. But there's some dogma that can come with this. Before I get into that, I'd like to thank EventStore for sponsoring this video. EventStoreDB is a new category of operational database built for event sourcing, CQRS, and event-driven microservices. For more EventStoreDB, check out the link in the description. And that's it, really. And whether you're using a monolith or microservices, it doesn't matter. You can apply this. However, there are some implications, and that's what this video is about. The first is when people start applying this pattern, they want to apply it everywhere, and that's really just not the case. There's absolutely nothing wrong with having your client reach out to your HTTP API and it interact with the database. Not everything has to be a message on the queue that the worker has to perform.
Right. For like, so he was referring to his authorization, authentications type stuff. Yes, your API can go authenticate directly to a database here, or its own database, like authentication database, whatever. Yes, that's not everything has to be put into a queue into a worker that just checks the authentication and then does no, that's not necessary. So, okay, that's kind of obvious.
It's just where it's appropriate. So it's not where everything has to be WebQ worker. No, you can still have your HTTP API that has to get data out of a database that could be for query purposes, even if it's an action, some type of command where it needs an immediate response. And that's the second issue people...
Right, it's the immediate response. It's the getting access to the database. It's not going to do some big process or something. It's just going to look up. That could be sync. That could be synchronous. But anything that could possibly takes longer than a second, it should use this queue worker type stuff. If you're actually doing some real work other than a search, yeah, it should be async.
Run into is that if you do have a legit use case where you're going to put a message on a queue and the worker is going to need to execute that, how does it communicate that back meaningfully? So there's different ways to do this. I'll have a link at the very end of this video that kind of goes into more detail. But as an example, you can have your HTTP API. It's putting that message on the queue. Our worker is going to pick up that work. It's interacting with our database, making some type of state change. How does it communicate that back to the client? One way of doing this is through something like WebSockets. If you're in the .NET space and using like something like SignalR, ultimately you have some type of backplane. It could be Redis, which ultimately I'm not really illustrating here, but that's going to be invoking something, telling your HTTP API that's hooked up that has that WebSockets connection to push that down to the client to communicate.
It could be WebSockets, it could be polling, it could be an email, it could be an SMS, it could be some other thing, some device you're running off somewhere There's all kinds of ways to do this asynchronous back to the browser. I mean, polling is pretty good for these short running pages. Like if you're just waiting for a response to come back, it's going to be deposited in a database someplace after this worker is done with it. Polling is fine. It's like once a second on the same page, and once the data is there, they can stop polling. I think that's acceptable. Other than doing a whole WebSockets arrangement, because that WebSocket stuff does kind of complicate stuff.
Communicate. And this is just a real issue and things that you need to overcome if you're doing background work. Another example I love to give is that it doesn't all necessarily have to be pushed to the client in that form, and it can still be dealt with asynchronously. My example of this is if you did an online order and your credit card was declined and that credit card processing was done asynchronously, well, you're not going to necessarily know in your browser. You might have closed your browser after you placed your order. Likely what you'll get is an email. It's still a form of notification, so it doesn't necessarily have to be dealt with all kind of in real time and pushed to the client. Yeah. There's different ways of pushing that information, such as email. It just really depends on your context and what type of work you're performing and how or when the ultimate client or the end user needs to be notified of that work is being successful or failing. Now, I also mentioned scaling in the WebQ worker pattern.
And that's why, like the synchronous stuff, you want to keep it under a second, You want to get the response off of that thing pretty quickly. If it's going to be a long-running thing, let the user know this is normal thing that's going to be long-running. It could take a second. It could take a minute. It could take 10 seconds. It could take 5. You warn the user. That's a normal course of business. But, I mean, not every piece of it has to be run like that.
Fits that bill because you're probably typically used to scaling out your HTTP API or your web portion that could be behind some type of load balancer, and you're just scaling out. You're basically adding more instances that are available for requests. In doing so, you'll notice here that I also made my database larger because if you're having more inbound requests, you're going to likely increase load potentially in your database, so you might need to scale that up.
Right. So what he's saying here, you could put these in different processes, like on different machines, right? These 3 things would be running on 3 different machines, handling the data load. And once you get to this level of have to use a load balancer and all that stuff, I mean, you've got a lot of users. So most of the applications I'm suggesting for this MicroMonopoly stuff is going to have under 100,000 users. But if you structure your app internally as a monolithic, a modular monolith, and get it ready for this stuff, as kind of KTOR is kind of set up for it. And if you design your app this way, like every worker is going to have access to its own database, not just one database, or at least if it's in one database, it'll be separate tables. Like one worker will use this table, another worker will use this table, so you don't have to worry about the lock. When you get when you can get a situation where things get locked up or are waiting for things too long, and you just want to make those kinds of things asynchronous. So that's why if you keep them separate, each worker accessing one table or each worker accessing its own database, you can then scale it up when you want to break that functionality out of your modular monolith and make it into a microservice or just a service. You can then scale that service up and down and have it access its own database, so you don't have to like pull it out of all this other stuff. That's where the problems happen, is when you have more than one worker accessing one database. That's where it gets a little hairy. When you want to split it up. In the beginning, it's super convenient just having everything touch everything. Yeah, I don't really think about it too much. That's why you usually, a lot of developers say throw away that. Do it. Go ahead and do it, but throw that away. If you don't really know what you're building yet, you build one like that and then you throw it away. But if you kind of already know what you're building, you're going to know where things are going to be asynchronous and where things are going to need to be synchronous. You kind of have it planned out. You don't have to do your 1.0 that way. You can build it in this modular way, in this monolithic way, preparing for breaking out a service when you need to, not from the beginning.
The same thing goes for the worker. If your HTTP API is producing that many messages on your queue, you're going to need to keep up to that. And you can do that by adding more instances of the worker. So again, I'll have a link.
That's why you'd want to build your monolith in a modular way, expecting to have to pull out and have to scale up the individual workers, right? So individual parts of your application are going to have more impacted loads. Like, it's only 20% of your app is going to have 80% of the traffic, and so those pieces you might need to scale those out at some point, not in the beginning. Just prepare it when you're writing the modular like this. I'm going to have some more examples of this. Like instead of using an external software queue that's running as a service somewhere like a Redis, you're internal. You're using a flow as our channel inside your application. It's like it could be just taken out and made into a separate process when time comes for that. So if you build it that way, this asynchronous internal, which KTOR is all set up for this stuff, then when the time comes to break it out, it'll be a lot easier.
link to another video at the end of this video that really talks about that, which really is the competing consumers pattern for having more work that you can perform concurrently to scale. But this is why the benefit of WebQ Worker is that likely though, when you scale one, you're gonna have to scale the other. And it's an important point to make about scaling is that oftentimes you're just moving the bottleneck. It's great that the WebQ pattern allows you to scale out, but just realize when you do so, you might just be moving the bottleneck. My example of how scaling out kind of our web HTTP API, but that may have the effect on the database, which I might not be able to scale out, but I have to scale up. Or I might need to have to scale out our workers because we're
Scale out means multiple copies. Scale up means bigger size, like a bigger processor. And man, you can scale up a monolith, a modular monolith, pretty hefty. You could have one machine with lots of RAM, lots of CPU. This is not 2016. These things are super fast. They can handle way more requests without having to go jump off to a microservices or even other services, just on one machine. A beefy, fat machine can handle a lot of stuff. So that's what it means going up or building out. That's what it means.
We're queuing more messages, but that might also affect the database. Maybe we have some other downstream services that I'm going to be adding load to. So ultimately, you really just end up moving the bottleneck, but it's great that you have these options to scale out. Now, regardless if you have a monolith or whether you want to do this within a microservice, the thing I really want to point out here is your HTTP API and your worker. While in my example here, they're separate deployable units, meaning that they could be a separate process from each other or a separate container. They could be the exact same instance, but
that's what I'm saying. Well, you should build it in the same instance. One instance, but build it modularly, like expecting that these things might break out into a microservice when that brings all kinds of complexity, right? You don't want to do that from the gate, but you can build it in a way so when the time comes, it's not going to be a total nightmare.
Mentioning for deployment and scaling concerns, you could separate them. However, they can be the exact same code base. From a development view, it could be the exact same code base, but when you build them, ultimately have two different entry points. Our HTTP API is built from the same code base, but it is using some top-level web framework to accept HTTP requests. And the same thing with our worker. It can be built from the same underlying code, but just has that top-level entry point that's consuming messages from our.
That's what he's talking about, like breaking it out into two different processes. So instead of having one machine run the whole app, you have two machines, like one's running this HTTP API and then it's hooking up to this other app that's doing this. So that's it. That's what he's talking about.
Our queue. So if you think about an HTTP request coming into your HTTP API, and then you just turn that into a message that you have something that handles and executes that message, whether it's being executed from your HTTP API or you enqueue it and it to be executed by your worker, it's the same underlying code. Obviously, this has trade-offs because if you're sharing that code, that means if you make some type of change, you need to deploy your HTTP APIs and your workers together.
Of course, yeah. I mean, you have to. If it's a monolith, you're going to deploy the whole thing at once. It's okay. All right. So you might have to have a persistent worker queue, or if you don't want to do any downtime. You might have to have all that stuff persistent. That's why maybe start with Redis out the gate to handle some of these mechanisms might not be a bad idea. It just depends on your use case. If you have 100 users or 500 users and they're not hitting your machine at 2 a.m. on a Monday, and that might be your low point to just to make everything easier on you. Just okay, it's down for a minute, okay. But there may come a point where it's like, okay, you can't do that anymore, right?
So it's monolithic in that sense, but that's not to say that you can't apply this just to an individual service and do this exact same thing. Another benefit of the worker is it can become a task scheduler. We've all dealt with systems where we have to either do batch jobs or we have long-running processes that need to run. If you've integrated with any other external services, maybe you need to do something on some interval. It may not involve your queue, depending on what type of task scheduler library you're using. Maybe you use a database, maybe you use an existing queue, but the case may be where maybe daily you have to go reach out to some third party to invoke some requests, get some data, interact with your database, but the worker is a great way to do this work asynchronously, and it can become a task scheduler. Now you might be saying, okay, well, this is just really a monolith. This can go many different ways that I'm not really illustrating. I urge you strongly to look at some of the other videos or look up the 4+1 architectural view model, because I'll say it again for those in the back, I say it enough if you've already watched my videos, is that logical boundaries aren't physical boundaries.
Yeah, I mean, for us, the logical and the physical will be the same, so we don't have to worry about that rabbit hole right now. But we should build the applications, these modular monoliths, in a way that when we want to pull this thing out, it's not going to be a nightmare. We're like, oh, okay, we're prepared for that. Because it's always going to happen. Some part of your app is going to be the bottleneck, and you need to scale that one up. So, okay, but you don't know which one. You don't even know if it's going to be successful. Why give yourself the headache before you've got your 10,000 customers? Get your 10,000 customers first, and then worry about scaling the thing. That's what this little MicroMonopolies are all about. That's what we're talking about here. Go give him a like and subscribe. And yeah, I'm kind of I'm a big fan of Derek Comartin at Code Opinion. He does get a little jargony, so I'll be your translator. Give me a like and subscribe. I'll talk to you soon. Bye.